Welcome to my YouTube channel. I am discussing solid state physics concepts for it is useful for CSI net, JLDL, whatever exams if you want to write in physics. So this topic is very important, that is solid state physics concepts. Today I am discussing about simple cubic structure. So what is simple cubic structure? I will draw here simple cubic structure. Simple cubic structure. So here one lattice point, one lattice point, one lattice point. These are the corners. So in this simple cubic structure, 8 corners, 8 lattice points. 8 corners, 8 lattice points. So what about characteristics? So what about sides? A equal to B equal to C. Then alpha, beta, gamma, that is equal to 90 degree. So simple cubic is a primitive unit cell. Simple cubic is a primitive unit cell. That means it has only one lattice point. N effective equal to one lattice point. Then A equal to B equal to C. Then I want to discuss N effective. N effective equal to here 1 by 8 into NC. 1 by 8 into NC. So NC is number of lattice point at the corners. Corners is 8. It is sharing 1 by 8. So 1 by 8 into 8, that is equal to 1. Number of effective lattice points in simple cubic structure, that is equal to 1. Number of effective lattice point, that is equal to 1. So next, what about primitive unit cell vectors? Primitive unit cell vectors. So already I said it is primitive unit cell structure. Primitive unit cell vectors. Primitive unit cell vectors. So here, so I am drawing. So this is simple cubic structure. Simple cubic structure. So here, this is x-axis. This will be y-axis. This will be z-axis. So this is the origin O 0 0 0. Then A 0 0. Then this will be 0 A 0 on y-axis. This will be 0 0 Z 0 0 A. So this is a primitive unit cell. So primitive unit cell is this one. So primitive unit cell vectors. So along x direction we are getting Ax. Then along y-axis Ay. Along z Az. So Ax equal to, that is A1 Ax along Ax along x cap. So along the x-axis we have x cap unit vector. So A2 A y cap, A3 Az z cap. So these are A1 A2 A3. These are primitive unit vectors. Primitive unit vectors. A1 vector, A2 vector, A3 vector. So these are the constants. These are the unit vectors along the xy directions. We can write like this also: Ax cap, Ay cap, then Az cap. So these are the primitive unit cell vectors. Primitive unit cell vectors. So I discussed here characteristics: A equal to B equal to C, alpha, beta, gamma equal to 90. That is primitive unit cell. Simple cubic is, so number of effective lattice points. So every lattice point is sharing with 8 identical cubes. For example, see, for example, this, if for example take this point above 1 uh, cubic below side. So this side 4. So this side 4. Total 8. It is sharing with 8 sides. It is sharing with 8 sides of 8 sides of crystals. So 1 by 8 into NC. NC is number of lattice points at the crystals. So NC 1 by 8 into 8, that is equal to 1. So we are moving one more. Next, volume of primitive unit cell. Already we got unit cell, primitive unit cell vectors. Volume of primitive unit cell. So we have to find volume. So these are the unit cell vectors. So we want to find now volume. Volume equal to, see, volume depends on vectors. Ax cap, Ay cap, Az cap. So A1, A2, A3. So volume equal to A1 dot A2 cross A3. A1 dot A2 cross A3. So these are the dot product of 3. So take this like this. So here X cap, Y cap, Z cap, A cap, X cap, Y cap, Z cap. So A1, A. So A 0 0 0 A 0 0 0 A. So what about how much you will get? A cube. You will get A cube. So value you will get A cube. So volume of primitive unit cell of simple cube is equal to A cube. Primitive unit vectors are X cap, Y cap, Az cap. These are the characteristic number of effective lattice point, that is equal to 1. So I want to discuss one more concept, nearest neighbors. Nearest neighbors. Nearest neighbors. So what about nearest neighbors? So nearest neighbors in simple cubic structure. Nearest neighbors. So here in simple cubic unit cell, see, I want to draw simple cubic structure here. Okay, then this is x-axis, this will be y-axis, this will be z-axis. So here this is a 0 0 0 a comma 0 0 0 a 0 0 a. So what about first nearest neighbor? I want to calculate first nearest neighbor distance. First nearest neighbor distance. First nearest neighbor distance. So for example, this is the origin, this is the point. So the distance will be first nearest neighbor, that is equal to A. So this will become A. This will become A. This is the A is the first nearest neighbor distance. How do we calculate? So point 1 0 0 to A 0 0, the distance between these 2 points. So the distance equal to 0 minus A, otherwise A minus 0 whole square plus 0 minus 0 0 minus 0 whole square under root. You will get A square. So D equal to A. First nearest neighbor distance, that is equal to A. First nearest neighbor, that is equal to A. So next, number of first nearest neighbors. Number of first nearest neighbors. For example, this is 1. This will become 1. So these 3. Then remaining, this is the front side. Back side also it will be there. So opposite to this one, 1. Opposite to this one, 1. Opposite to this one. So total 6 you will get. Total. So number of nearest first nearest neighbors equal to 6. So for this shortcut, I have one shortcut for this one. So what is that? Number of nearest neighbors, number of nearest neighbors equal to 2 power 2 power non-zero 2 power non-zero coordinate 2 power non-zero coordinate into 2 power non-zero coordinate into number of coordinates, number of coordinate factorial by number of equal coordinates, number of equal coordinates, number of equal coordinates. See, this is the formula for number of nearest neighbors. So what is the formula here? Number of nearest neighbors, 2 power non-zero coordinates, 2 power non-zero coordinates into number of coordinates factorial by number of equal coordinates, number of equal coordinates. For example, we can apply for this one. So here a00 a00 from 002. So number of nearest neighbors, 2 power non-zero coordinates, 2 power non-zero coordinates only 1 into number of coordinates, that is equal to 3 factorial, 3 factorial by number of equal coordinates, 0 equal coordinates by 2 factorial. So 2 power 1 2, 3 into 2 by 2 into 1. So 2 3 is 6. So we can calculate like this. Can calculate like this also. So formula for this one, number of nearest neighbors, 2 power non-zero coordinates into number of coordinates factorial by number of equal coordinates. So this is first nearest neighbor distance I calculated. I am going to second nearest neighbor. Second nearest neighbor. See, we can, by looking also we can calculate second nearest neighbor. For example, this is x-axis, this is z-axis, this is y-axis. So one more part. This is the first nearest neighbor distance A. So I want to calculate the distance to this point. So for example, x-axis. This point is in xz plane. Xz plane. This is xz plane. Xz plane means A 0 A. A0 coordinate for this point. So in xz plane, the distance between from origin to this point 0 0 to A0 A. So I want to calculate second nearest neighbor, second nearest neighbor distance D equal to, see what are the points here, 0 0 2 A0 A. So A minus 0 whole square, 0 minus 0 whole square, A minus 0 whole square. So that is under root A square plus A square, 2A square. So root 2A. So we calculated here second nearest neighbor distance. Second nearest neighbor distance. So this is the point. So this distance is nothing but root 2A. This is distance is nothing but root 2A, second neighbor distance, second nearest neighbor distance. This is the A is first nearest neighbor. This one root 2A is second nearest neighbor distance, second nearest neighbor distance. Then how many second nearest neighbor, number of second nearest neighbors? So how many are there? So we can use this one. What is A0 A? 0, see number of second nearest neighbors. Second nearest neighbors. So calculate, for example, A0 to A0 A. So we will see 2 power non-zero. Non-zero is only 1. Non-zero, so A is a 2 power 2. Then number of coordinates. Number of coordinates 3 factorial by number of equal coordinates 2. Number of equal coordinates 2 factorial. So 2 power 2, 4 into 3 into 2 by 2. 4 3s are 12. So Number of second nearest neighbors will be 12. Number of second nearest neighbors will be 12. This will be 12. Okay, second nearest neighbor distance will be root 2a. So like this we can calculate third 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 nearest neighbors third nearest neighbors distance. Third nearest neighbor distance equal to root 3a. The number of third nearest neighbors third nearest neighbors will be 8. So see, I want to discuss root 3a. So this is the first nearest neighbor 0 0 to a 0 0. Second is nearest neighbor distance a 0 0 to a 0 a. So this will be, what are the coordinates for this point? A comma a comma a. So this will be third nearest distance. First one a, second nearest neighbor root 2a. This will become root 3a. Root 3a, third nearest neighbor distance root 3a. Number of third nearest neighbors will be 8. Number of third nearest neighbors will be 8. Okay, this is I discussed in simple cubic structure. I want to discuss some more concepts on simple cubic structure in the next video. So I discussed in this video simple cubic, what are the characteristics, that is a equal to b equal to c, then alpha beta gamma equal to 90 degree, then number of effective lattice points 1 by 8 into 8, 1 by 8 into 8, each corner lattice point sharing with 8 identical cubes. So effective lattice point will n effect equal to 1 by 8 into 8, that is equal to 8. I discuss primitive unit lattice, primitive lattice vectors. So a1, a2, a3, ax cap, ay cap, az cap. So I calculate volume of primitive unit cell, that is equal to a cube. Then I discussed nearest neighbors. So I discussed here first nearest neighbor distance for simple cubic is a. So number of first nearest neighbors will be 6. Second nearest neighbor will be root 2a. Number of second nearest neighbors will be 12. Third nearest neighbor distance will be root 3a. Number of third nearest neighbors will be 8. So these concepts I discussed today. So I will discuss tomorrow the next characteristic of simple cubic.